The plate tectonic theory. Now, as you are seeing in this cover slide, the word theories are given. Why is the word theories given? Because actually there has been several theories to attempt to explain. Like over here you can see some mountains, over here you can see some magma, volcanoes, etc. So it is an attempt. There has been several theories which tries to attempt why the mountains or the earthquakes or the volcanoes, the earthquakes, the volcanoes, etc., why they occur, and wherever they are occurring, why they occur at that place, or the various types of deformation events, or how the various continents has been shaped. So there has been various theories, and we can divide these theories into basically two types. One is the late 19th century theories, and the other one is the Wegener's theory of continental drift. Now we have already studied about the Wegener's theory of continental drift. Now, when we study the late 19th century theories, there we find that there are two theories in the late 19th century theories. One has got to do with contraction of the earth due to cooling, and the other expansion of the earth due to heating. Now, this is a very common physics law that when anything contracts, when anything cools, it contracts. When anything heats, it expands. So this is a very common physics law which is being taught in class 8 or 9. So what happens for the first case, that is contraction? Now all of you have seen an apple. Now take the example of the skin of an apple. Now what happens when the interior dehydrates? The skin of the apple also shrinks. Now we can explain that thing with respect to earth also. So this explains the various compressional features, the shrinking features, the compressional features. Now what could be the various compressional features? The various folds, the thrusts, etc., the rifts valley, the oceans, basins, etc. And the next one is the expansion of the earth due to heating. Now, with this was suggested after the radioactivity was discovered. So this could explain why the various continents are broken up. Also, this could explain the various features which could not be explained through the contractional features. So the expansional features could be explained through this. So these are the two kinds of, or the various expansional features of the continents, how the continents, because of expansion, they got broken up. So the extensional features could be explained. And you already know about the of the continental drift theory, which was given by Alfred Wegener. So according to this, he put together his evidence, as we had seen in the earlier class. He had put together his evidence to formulate his theory that the continents have moved together over the surface of the earth. And we already know that there was a supercontinent called Pangaea, and how it broke up and it drifted apart. Now, most of you have seen a raft like this. Now, like the raft is flowing on this lake, similarly, the earth is not a solid lump. What it is like it is just like this raft, like the crust. So the earth is like the raft or the crust, and this continental crust is floating on the mantle or the lake, so, or the oceanic crust. So the continental crust is floating on the oceanic crust. Now let us see what are the plates. What do we mean by the plates? Now, in one of my earlier lecture, I had already explained about the continental crust and the oceanic crust, and the reason why the continental crust is floating over the oceanic crust. So this continental crust, just like I had explained in the previous slide, this continental crust, it is made up of the lithosphere. Now the density of the continental crust, if you remember from the earlier lecture, is always less dense. The continental crust is lighter, while the oceanic crust is heavier. So the continental crust it floats over the oceanic crust, or we may say that the lithosphere is what? The crust and the uppermost mantle. It floats on the asthenosphere. So it floats horizontally on the asthenosphere. Now the plates, as you are seeing over here, the various plates are given. So these are around 100 kilometers, and they can be divided into two types, that is the oceanic crust and the continental crust. So the plates, like for example this Pacific crust, it is almost fully oceanic crust, while the North American crust is again continental plus a part is oceanic crust. So it can be divided into both continental and oceanic. Now these plates are what? They are rigid bodies, and these are aseismic bodies. What we mean by seismicity? Seismicity means, like over here you are seeing the colored zones over here. The colored zones over here, these are seismic zones. Seismic means they must have various features of volcanicity or earthquakes, etc. So the plates are actually aseismic zones, these plates, where we have very few earthquakes. But where do we have the earthquakes? The earthquakes are associated with these zones, that is the plate boundaries, these plate boundaries. So plate boundaries are actually seismic zones. So if you see over here, or we will see in the other slides, if you see over here, these are the boundary zones of the plates. So the boundary zones of the plates are the seismic. Plates can be divided into three major types: the major plates, the minor plates, and the microplates. So these are divided based upon the area that it encompasses. So a major plate, like these are the major plates which you are seeing over here. So the major plates must be greater than this much length. This much area must be greater than 20 million square kilometers. So most of these major plates consists of both the continents and the oceanic areas. So you can see the major 7 plates over here. Now these are the minor plates and the micro plates. So the minor plates, they must be less than 20 million but greater than 1 million kilometer square. Whereas the microplates are still lesser in size, so they are lesser than 1 million kilometer square. Plate boundaries are seismic zone. Now why so? So before that, plate boundaries can be of three types. So what are the three types? So what is a boundary? As you are seeing over here, these are the meeting point of two plates, or as you have seen in the previous slide, those are the meeting points of the plates. Now the first type that we will discuss is the divergent plate boundary. So the first type of boundary that we will be discussing is the divergent plate boundary. Now as you are seeing over here, it is diverging, that it is going apart. This is also known as constructive plate margin. Constructive plate margin or constructive plate boundary, or divergent, because this is diverging, this is moving apart. Now these areas over here, see this picture. So these areas are the oceanic ridges. These are known as the oceanic ridges. And see, magma comes out of these ridges. So when it diverges, there is a gap in between, and through this gap magma comes out. As the magma is coming out, see, as magma is coming out, where will this magma go? This magma go on either side. See these two arrows. So as this magma is coming out, it is going to either side. It is going to the either side. So as it is going to the either side, so what is created? This oceanic crust is created. This oceanic crust is created. So oceanic or new oceanic lithosphere is created. So this comes outside, this magma comes outside. As it is coming outside, it is coming, it is being pushed to the either side, and as it is pushed to either side, new oceanic lithosphere is created. Now, for example, there is there is new oceanic lithosphere here, there is new oceanic lithosphere over here. Now, as again new magma will come out, then what will happen? This new magma will push the old magma this side. This new magma, as it will come out, since there is already magma over here, there is already lithosphere over here. So this new magma, it will push this towards this side, because obviously this won't come over here because this new magma is coming out. There is more pressure over here, so this will be pushed to the either side. So because of that, new magma will be deposited over here and the old magma will be pushed farther away. So new magma will be deposited over here while the old magma or the old oceanic floor will be pushed farther away. So over here it is written, the age of the oceanic crust becomes older from the ridge. So near the ridge, it is new magma or new oceanic crust or new oceanic lithosphere, while away from it is the old lithosphere or the old magma. Now, the next type is the convergent plate boundary. So over here you see that this is also called as a destructive plate boundary. So over here you are seeing over here that instead of going apart from each other, what is happening over here? It is actually coming towards each other. So when it comes towards each other, one of the plate will subduct beneath the other. Like over here, this plate is coming and there is another plate over here. So one of them, see, it is going beneath the other. It is going beneath the other. One of them is going beneath the other. So when that happens, when one of them goes beneath the other, so where it goes, so this position where it is going beneath the other, this particular place is called the oceanic trench. So over here, see over here, this oceanic lithosphere, as it is going down, so going down, this is another plate, this is one plate, this plate is going down. So the point, so the area where this is going down, this is called as the oceanic trench. The other one was oceanic ridge, from where new new magma was coming out. And this is the place of oceanic trench. Oceanic trench means where magma is lost. Ridge is the place where new magma is formed. Trench is the place where oceanic lithosphere is lost. It is just the opposite. So from divergent plate boundary is the place for new magma creation, new lithosphere creation, or the oceanic ridge is the place for new magma creation. Convergent plate boundary is the place of oceanic trench where new where this oceanic lithosphere is lost. And the sinking plate here, this sinking plate thus becomes a subduction zone, because this sinking plate is subducts, it goes beneath, so this becomes a subduction zone. And this zone is also called the Vadati-Benioff zone, the Vadati-Benioff zone. So the Vadati-Benioff zone is the zone where most of the earthquakes are located. So when this goes down, when it sinks beneath the other, then there will be various magma, there will be magma, etc., and there will be various forms of earthquakes. So the zone where the maximum amount of earthquakes, etc., are formed, that is the Vadati-Benioff zone. Now we see that various types of convergent plates. Till now, we had seen about convergent plates, but convergent plates are basically of three types. So what are the types of convergent plates? Just like you're seeing over here, ocean, ocean continent, and continent collision. Now, what happens in which and why should we study each of them in details? Now, in an ocean continent, in an ocean convergent plate, I have already told you that the oceanic plate is more dense while a continent plate is less dense. So, in an convergence, one of the plate which is more dense of the two plate, that will subduct, that will go beneath the less dense one. So in an ocean, when two oceanic plates converge, the more denser of the two will subduct beneath the less denser oceanic plate. Now, this is a common phenomena. Just keep this in mind. When two plates converge, then the denser will subduct beneath the lesser dense. So, keep this in mind. Less dense means it will float. Dense means it will sink. So, keep this in mind. So, whether it is ocean or ocean continent or continent, in everywhere, the greater dense, the more dense will sink beneath the less dense. So, when this happens, similarly, the denser will subduct beneath the other. Where it will subduct, it will form a trench along the boundary. So this will result, see over here what is happening when this is coming down, this will result in the creation of magma. So the magma, where it will come out, it is coming out through this picture. You can see it is coming out onto the surface. So when it comes out, there will be a continuous flow of magma. When this happens, there will be a continuous flow of magma. And because of this continuous flow of magma, there will be continuous volcanic eruptions. When two oceanic plates converge, there will be lots of magma creation when this will subduct, because this subducts very low, quite low down. And when this happens, because interior of the earth is very hot, since it is subducting very much interior, going very much down towards great depth, so a lot of magma is created, lot of displacement occurs, so lot of volcanic eruptions and earthquakes occurs. So because of this constant volcanism and constant earthquakes, this area will form the over the surface, this area will form a chain of volcanic islands. And when we have a chain of volcanic islands, we call this as an island arc. For example, the Japanese island arcs. If you see on the map of Japan, you can see that there are a lot of islands in the Japanese island arcs. Even in the Philippines area, if you see, there are a lot of small islands in the Philippine areas. Next, we come to the continent and the ocean, or the ocean continent convergence. So over here, the greater dense is the ocean. So the ocean will be thrusted down. So when there is an ocean continent convergence, so as you are seeing over here, this is the continental plate, this is the oceanic plate. Oceanic plate being more dense, this is subducting beneath this oceanic plate. But there is a difference between subduction of here and subduction here. The subduction here, as you are seeing, it is going deep down. But the subduction here, as you are seeing, it is much more shallower. See the depth, it is much more shallower than this. Another difference is, see this edge over here, the locked zone. This is building up because of convergence. The edge, the lithosphere over here, the edge in this, the lithosphere in this continental edge, and the lithosphere in this oceanic edge, both of this buckles up. Both of this is this is forming a wedge kind of a shape, just like you are seeing over here. So this is becoming the sort of a mountain. So this takes the shape of a mountain when this edge of this oceanic plate and over here this continental plate, both of them, because of convergence, this buckles up in the form of mountain. Plus another thing what also happens, because this is a trench zone, but this trench is much shallower than the trench over here. So over here, the magma or the earthquake or the volcanoes that are formed are not so deep seated like here. It is much more shallower seated over here. And these volcanic eruptions are not such continuous as we find over here. So the volcanic eruptions along the border over here, there are also volcanic eruptions occurs. They form a chain of volcanic mountains instead of island arcs, because they go on happening. Here a chain of mountains, volcanic mountains are occurring, and you are seeing how this mountain is happening. This mountain is happening because of buckling of this edge area. So instead of island arc, what is happening? A continental volcanic arc is happening. Volcanic arc. This is also called as a Cordilleran convergence, because this results into extensive mountain systems, so Cordilleran convergence. And the examples are given for ocean continent. So these mountains are result of ocean continent convergence. Next on, we have continental collision. This is quite different from these two. See this over here. This continent crust, and this is another. Now, in most cases, when two continental plates are converging, now I have told you a basic principle, that is continental crusts or continental plates are much less denser than oceanic. So because they are less denser, so in both the cases, neither of the plates subducts or goes down. Or even if they do go down, over here, see, I have given an example of not going down and going down. So even if they do subduct, then the subduction zone won't be deeper than 40 to 50 kilometers. Not so deep down, not so deep down. So the subduction zone won't be deeper than 40 to 50 kilometers. So the least subduction occurs in this, that is a continental collision. Least subduction occurs, and this zone, that is this zone, the 40 to 50 kilometers where it subducts, this is also known as the suture zone. Suture zone. Now we will see about this in the later slide, in this slide. So this zone is called the suture zone, Suture, suture zone. And the two plates generally, when they don't converge, when they don't go down, when they converge, what is happening? See what is happening over here. They are buckling up. In this video over here, you are seeing they are buckling up. So they are buckling up, they are getting folded. This is a folding, and because of too much of folding, over here you see a crack has developed. A crack has developed. So fault is also occurring. So they are buckling up, they are folding, they are faulting. So this is generally we find the various mountains, the various fold mountains when two continental collisions. Because of continental collisions, here you are seeing the various fold mountains. Himalayas, they are the classic example of continental collision. Now there are various terminologies as you are seeing over here. What is an arc or an island arc? So arc is a narrow chain of volcanic islands. So island arcs, especially when it is volcanic islands, that is island arc. And arc can be mountain chain of mountains also. Then we have continental arc, and we have the accretionary wedge. So these are the various terminologies. Now let us come to the third type of plate boundary, which is called the transform plate boundary. Before this, you had seen either they are converging or they are going apart. But here in this, you see they are not coming inside, they are not converging, or they are not going apart. What is happening? They are just sliding past each other. This is coming this side, this plate is coming that side. So they are sliding past each other. So What is happening over here? See, because of this sliding past, you can see over here there is friction because of sliding past. You can see these frictions are occurring. This is also called as conservative. Another terminology that is used for transform plate boundaries are conservative, because they are conserving, they are not diverging, they are not uh, constructing anything, they are just conservative. So just like, for example, take the example of two cars. If they slide past each other, what will happen? There will be various friction will occur. Similarly, over here, friction is occurring, and this is the result. Because of friction, this is occurring. This is earthquakes, etc. are occurring. So generally, the region of transform fault, this is the region of transform fault that is called the San Andreas fault. This is beside North American plate. So this is the region of various shallow focus mountains, shallow focus earthquakes. Now, what is the ring of fire? Maybe many of you have heard about this. The ring of fire, the terminology of ring of fire in various competitive exams or various exams, this comes the ring of fire. Now, over here, you can see the pictorial representation of the ring of fire. It is given. So this is a, as you can see the shape, it is a horseshoe shape, and around 40,000 kilometers. And where this is found? This is the Pacific Ocean. So this is found in the Pacific Ocean. Now what this is, why this is called the ring of fire? Now as you are seeing over here, this region has got all sorts of plate boundaries. All the plate boundaries that I have told you right now, the constructive, the destructive, the conservative, etc. Every kind of plate boundaries is found over here. And this particular region, since every kind of plate boundaries is found over here, till now I have told you what is the result of the plate boundaries, what happens because of the various movements of the boundaries. So this is the region, this particular region is the area of 90% of the world's earthquakes, and almost 81% of the world's the largest earthquakes. 90% of the earthquakes and 81% of the world's largest earthquake. In fact, almost daily this region, especially the Japanese islander arc, almost daily they have to face earthquakes. And this is the region where the various, in fact this is a direct result of plate tectonics. This region is a direct result of plate tectonics. You can see the various movements in this slide over here. So this is a region where various various plates are either subducting beneath the other, or they are buckling up. So like this, for example, over here, this African plate or the South American plate, this is moving this side, this is moving this side, whereas this plate over here, this is moving this side. So these are converging. Again, for example, over here, this Eurasian plate. This Eurasian plate is moving this side, this is moving this the other side. So this is the region where various plates are either converging or they are destructive, they are moving towards each other, like this particular plate, this Nazca and this South American plate. So this Nazca and the American plate, this Nazca plate over here, what is written? Destructive. That means Nazca plate is moving towards South American plate. So the Nazca plate is getting subducted beneath this South American plate. So again, this Cocos plate, see this Cocos plate over here. This Cocos plate, this is being subducted beneath the Caribbean plate. So this is the place where various kinds of these plates, they are either moving apart or coming towards each other. So there's always a steady state of collision in this region. Because of the steady state of collision, always there is volcanic and already I have told you that this is the region of island arc, the Japanese island arc. This is the Philippines island arc. So this region being the island arc, that means this is the region of the steady state of collision between the various plates. So that is why, because of the steady state of collision, there is always volcanoes And I have already told you, when two oceanic plates they converge, we have a steady state of volcanoes. So this is the area where two oceanic plates are converging. So there is always a steady state of volcanoes. Plus there are other kinds of plates which are either destructive or constructive or conservative, etc. Over here we have the conservative margin. That is why this region has got so much of volcanoes, so much of earthquakes, and that is why it is called the ring of fire. Now this particular now what are the reasons that yes, it is really, we get to know what are the proof that yes, there we have plate tectonics. Now the proof is seafloor spreading, just like you are seeing over here. I have already told you about these two things, oceanic ridges and oceanic trenches. Now, for example, I have told you what happens in ridges and what happens in trenches. Now, for example, this over here, from here, new magma is coming up. Now, if new magma is coming up, what is happening? See, this thing, oceanic, this crust, oceanic floor is getting spread. Almost, this is like a conveyor belt. I think many of you have seen in an airport the conveyor belt. So this is also like a conveyor belt. So this is acting like a conveyor belt. So new magma is going up, coming up, and they are spreading on either side. Now, supposing if there is no plate tectonics, then what would happen? This would go on spreading and spreading and spreading. So this does not happen like that. So as this is coming up, this is again the oceanic crust is lost in these trenches. So since I have already said that the continental crust is floating above the oceanic crust, that means when this is getting spread, obviously the floating continents will also move with them, because the continents are floating on the oceans. So when the oceanic floor will move, then it is very much obvious that then the continents which are floating above them will also move. So this is one of the point, that yes, plate tectonics do exist. The other is this, the paleomagnetism. Now what is paleomagnetism? See over here, this is the Earth's geographic north. The Earth's geographic north and south is fixed. We can't do anything with that, with the geographic north and south. But what it changes is the magnetic north and south. So the magnetic north and south, they interchanges themselves every lakh couple of years. So it was, and generally when, like for example, take this picture over here. So for example, if the Earth's magnetic north is this side, so the new magma or the lava which is created, or new rocks which are created, the minerals or the magnet or the grains in them will be aligned according to the, and that is the magnetic minerals that is there will be aligned according to the Earth's magnetic north or magnetic south. This is very much obvious. So because of the Earth's magnetic north or the magnetic south, alignation of the Earth's magnetic north or south, supposing in a particular year, whatever rocks are formed in that particular couple of years, then the minerals in them will be aligned according to the Earth's magnetic north and south, not the geographic north and south, magnetic north and south. So if there is new, again supposing again a couple of years later, we have the Earth's magnetic north and south is this direction. That means then the magnetic grains will align themselves according to this direction. So what is happening? It was the geophysicists, they studied the Earth's, the various piles of lava, and by studying the various piles of lava, they saw this imprint was the imprint of the magnetic north and south. Now see this particular picture over here, or this picture over here. As new magma is coming up, it is getting imprinted, the grains are getting imprinted according to that. Now they are getting spread to either side. When they are getting spread to either side, Then again fresh magma is coming up, so this is plus sign, maybe this is north, this has been aligned towards the north side. Now new magma is coming up, so this is going to this side. Then again this particular is minus, that is maybe imprinted, it has been imprinted as south, the earth has reversed itself, so new imprint has occurred. So through this, through the reversal of magnetic field, we can understand that yes, plate tectonics has occurred. So supposing this particular place, this has occurred long back, this is maybe this is plus, this is the magnetic has been done according to plus, then this is again minus, so that means this has moved to this place, that is why this has moved from the ridge, that is why though this is away from the ridge, but on either side of this the ridge we find same type of magnet, we find a magnetic field. So here also same type magnetic field, here also same type magnetic field. That means this has moved to either side and the same imprint has occurred on both the sides. Similarly over here, same imprint has occurred in this side also and this side also. That means it has moved from either side. Another this thing evidence that was found is that it was seen that the depth and the age of the oceanic floor goes on increasing away from the ridge. That means the depth and the age is more here than here. The reason is why? The reason is over here you find comparatively younger magma, because from this ridge new magma is coming out. As it is coming out, it is moving to either side. So over here you find older, but over here you find newer. So through this, this is also a proof that plate tectonics has occurred. So this has moved. Because it has moved, so the depth is much more and age is much more. The other evidences are the various continental drift evidences, which I had told you in the previous lecture of continental drift. So the evidence of jigsaw feet, also the evidence of Pangea. So if Pangea existed, then obviously the that means right now, since we don't have Pangea, that means obviously the continents have drifted apart, or also the same is plate tectonics. And what is the hotspots? The hotspots are the areas of the rising plumes of hot mantle. So these areas we see generally, these hotspots must be in the plate boundaries. But we see that these hotspots are sometimes found within the plates. So this only suggests that the plates have moved. Because it has moved, so these points have also moved. So the landform evidence again, so the reappearance of mountain slides. So this is again the various proofs that we had spoken about in the continental drift theory. So the same proofs also same evidences we can also use for plate tectonics. And with that, we can also use the proof of Pacific Ring of Fire. I have already told you about the Pacific Ring of Fire. Again, Wegener's evidence of fossils is also proof enough that plate tectonics has occurred, because these things, these flora and fauna, they are found in all the southern continents. That means that these were all once upon a time at a particular place, but now they have all moved apart. The Wegener's evidence of lemurs and Wegener's climatic evidences, I am not going deep into these evidences because I have already told you about these in the continental drift theory. So I am not going into deep into all these evidences. Now, what causes the plate tectonics? Now, as you are seeing, this the convectional hot, less dense the materials, they are rising. And these are called the convectional currents. See, these are the convectional currents. These convectional currents, when they rise to from where they rise from the ridges, and when they rise, they are in the liquid format. and then when they rise, they move on the either side. There is heat transfer, and because of heat transfer, convectional current occurs. And when convectional current occurs, then from these points, it moves up and it expands. When it expands to either side, then it will cool from the surrounding. When it comes up, it will move to either side. So when it will see over here, this is coming, hot magma is coming. When it is coming upside, then over here temperature is much more less, so it will cool, it will go on either side. So as these materials, they will sink. So these are, see, this is moving up, spreading to either side, and then again they will sink. They will again become dense, they will again sink, they will again become dense, because when it is getting cools, it will become dense. Anything when it is hot, it will be less dense. When it is cool, it becomes dense. This is again a very common law of physics. So it is very hot over here because interior of the earth is hot, so it is less dense, it rises, it moves to either part, either side. See, it is moving to either side. Beneath the beneath the crust, it is moving to either side. When it is moving to either side, its temperature falls. When the temperature falls, again density rises, physics law. When density rises, it will do what? It will sink. See, it is sinking. So in this way, a convectional current occurs. See, a convectional current occurs. It is moving up, going to either side, sinking. Again, when it is sinking, again heating up, again moving up, again going to either side, again sinking. So a cycle occurs. This cycle is called convectional current, convection cell. Then this results to movement of the asthenosphere, because some movement is occurring. So see, when this is going to either side, this is coming to either side, so this continue beneath the crust. So with that, it is also what is written, slab pull. With that, it is also pulling, the lithosphere with it. See, the convection current is coming to this side. While it is coming, it is also pulling the lithosphere with it. While it is pulling the lithosphere with this, so pulling means what? Displacement. So displacement is what? Plate tectonics. So there is displacement of the plates. When it is moving to either side, this particular thing is moving this side. So when it is moving this side, it is also moving the oceanic crust and the continental crust with it. When it is moving, there is displacement. When there is displacement, this is nothing but plate tectonics. So all these things results in the formation of the plate tectonics.